Mount Hood is the gentle giant of the Cascade Range, but since yesterday there have been more than 100 small earthquakes up on the mountain.
Scientists are grappling with a rapidly unfolding emergency on Mount Hood. A moment of striking uncertainty, mounting alarm, and expanding risk. Early this morning, sensors along Oregon's most iconic peak triggered a wave of urgent notifications across research networks. What began as a few lines of code, spikes in instrument readings, has accelerated into a stream of warnings that have left the scientific community tense, the public on edge, and the landscape itself shadowed by a sense of looming danger. Within minutes, reports swept through the Pacific Northwest, plumes of mysterious gas and steam billowing from the volcano's upper flanks, curling above the tree line in broad, opaque ribbons. Sightings multiplied. Videos poured across social media, each one showing Mount Hood shrouded in rising white clouds, some drifting silently skyward, others erupting in sudden bursts. What started as faint, almost routine emissions quickly transformed into a much more dramatic event. The mountain's usual gentle exhalations giving way to urgent output. Locals and hikers, from Portland to the high meadows, called it both beautiful and ominous, a reminder of the deep energy sleeping underneath Oregon's landscape. Behind the drama, scientists at the Cascades Volcano Observatory were confronted with something more profound than a meteorological trick of the light. In the data, in the hiss of the steam, in the staccato of real-time readings, they recognized a deeper alarm. This was not business as usual. Instead, it was a break from the ordinary, a sudden and unexpected surge in volcanic gas, emerging with a force that defied earlier trends and forced experts to rethink their assessments. Already, emergency meetings were underway, seismic records reviewed, and panoramic feeds closely watched for any sign of further escalation. This activity atop a centuries-old massif is more than a fleeting geological hiccup. It is a riddle unfolding in real time, charged with uncertainty and the possibility of upheaval. Scientists, residents, and first responders face pressing questions. How dangerous is this surge? How long might it last? Or could it signal something more severe ahead? Has the period of predictable calm truly ended on Oregon's most famous peak? Yet this is only the start. The danger does not begin and end with what is visible. What unfolded this morning across forests and fields, the plumes, the strange hush, and the gathering of raw energy may only be the surface sign of deeper processes. For every visible burst of gas vented into open air, countless forces stir beneath the bedrock. These are not the soft sighs of a dormant mountain, but the echoes of transformation, stirring motion beneath stone. As scientists race to interpret the new signals, the urgency grows. What's appearing at the surface could be but the first flicker in a longer chain reaction, one that might reshape the landscape, rewrite the region's recent history, and revise many long-held assumptions about what Mount Hood is capable of. So the question remains, what is really happening beneath Mount Hood, and why do these gas emissions send such ripples through the scientific world? The answer touches the core of volcano science, and the limits of certainty even within modern monitoring. The earliest alarms sounded just before sunrise, when automated sensors on Mount Hood's upper flanks recorded an abrupt and steep surge in gas emissions. This was not the typical up and down recorded on calm days, but a sudden and significant jump. Concentrations of water vapor, sulfur dioxide, and other volatile compounds rising well above baseline levels, enough for seasoned experts to double-check their data and run more simulations. Almost at once, locals began posting footage, proof that something extraordinary was underway. From Timberline Lodge to remote trailheads, people reported seeing veils of white steam, bursts of smoke floating skyward, and hearing a sound like water boiling beneath stone. Helicopters took to the sky, and images were broadcast on local news. Within hours, a localized curiosity had edged closer to regional alert. Mount Hood, tranquil and familiar one day, suddenly the center of anxious attention. At the Cascades Volcano Observatory, Dr. Lina Vasquez, one of the region's leading volcanologists, was among the first to address the public. This is not typical outgassing, she explained. The rate, the composition, and the speed of onset all point to unusual volcanic activity. Our team is analyzing data to determine whether this marks a new phase of unrest. Her words reflected both caution and urgency. When Mount Hood behaves out of character, the stakes for the entire region rise. Subscribe now for continuing updates as the situation unfolds, exclusive expert analysis, and in-depth coverage of every significant discovery at Mount Hood. Your support helps ensure we can bring you this information promptly. Hit the bell icon so you never miss a crucial alert. As this story proves, anything can change in an instant. At the technical core of the crisis is a phenomenon as subtle as it is important: the sudden migration of deep volcanic gases to the surface, recorded in real time by a network of sensors, aerial cameras, and seismic monitors. Scientists tracked not only the volume, but the speed at which gas reached the surface. Ordinarily, Mount Hood vents only a small amount of steam and gas, residual heat escaping from its magmatic core. But overnight, readings soared, with concentrations dense enough to prompt further on-site investigation. The nature of these gases, primarily water vapor and sulfur dioxide, along with trace secondary compounds, offers important clues. Rising through fractured rock, the emissions passed through a previously quiet channel, a burst-steam heating pipe, an underground conduit rarely so active. This time, however, its outflow was unambiguous. The pressurized emission, confirmed within a day by field teams, originated just below a fractured cap near the summit. The resulting plume punched upward, shifting cloud cover and sending tremors through the ground. Subtle vibrations and local heat signatures hinting at movement and unrest at depth. For Dr. Vasquez's team, the implications were significant. Our immediate concern is not just the current outgassing, she said at a press conference, but the potential for escalation. Sudden gas migration can be linked to depressurization in the magma system or shifts within the hydrothermal system, any of which could serve as a precursor to instability or even eruptive activity. In plain terms, deeper breathing within the mountain can sometimes foreshadow more dramatic events. What unsettled experts most was not just the speed of the shift, but its unpredictability. Mount Hood's recent geological record teaches a sobering lesson. Most eruptions do not begin with dramatic ash plumes, but with subtle increases in gas, bubbling hot water, and deep rumbles heard only by sensitive instruments. Scientists know the quiet signs of unrest, but what sets this event apart is how quickly visible symptoms appeared. Now, the region faces a critical threshold. Will this eruption of gas fade into the record as a minor anomaly, or does it mark the earliest stage of a much more consequential episode? Is this a false alarm, or is it the first warning signal of a full-scale volcanic event, one that could alter the regional landscape and require decisive emergency response? Science, built from decades of volcano monitoring and now sharpened in the crucible of a real-time emergency, offers only provisional answers. The distinction between regular volcanic breathing and a serious transformation is subtle, often recognized only in hindsight. Monitoring dashboards now flash with new urgency. Interpretive skills are tested, and the limits of even sophisticated equipment become painfully clear in the face of nature's uncertainty. As scientists race to decode every signal, they explore a landscape that's both familiar and inscrutable, a mountain meticulously mapped above ground, but full of mysteries below. And as each new gas reading redraws lines of risk, a central question remains. What is Mount Hood trying to tell us? And how long before observations become urgent action? If this is only the early stage, what may follow?
While public attention centers on visible findings, the plumes, the swept slopes, and the trembling ground, the true risk lies deeper, hidden from view. Underground, cascades of change ripple outward from the source of Burr steam eruption, signals difficult to interpret, fraught with uncertainty and potential danger. The first important clue arrived from an array of ground sensors placed below the mountain's southern flank. These instruments pick up subtle temperature and pressure shifts, and this morning they recorded a flickering, intermittent surge, not a steady and harmless venting of steam, but bursts of energy expelled in unpredictable pulses. This burping can be a means for volcanic systems to relieve pressure, or, if equilibrium is lost, could push conditions toward instability. Aerial overflights later confirmed earlier suspicions. Rising gas traced a path from the Burr steam heating pipe through a fracture beneath the upper ridge. Roiling emissions, thicker and denser than any recorded recently, enveloped upper slopes and spurred immediate safety measures, leading officials to block access to parts of the mountain. For the first time in memory, snowfields and crests familiar to hikers were shrouded in mist and vapor. Dr. Vasquez's team reported, "What we observe is a major change in the surface energy of the volcano. Increased emissions and rapid venting can trigger secondary hazards, such as minor landslides, ground deformation, and the sudden warming of local streams. In effect, Mount Hood is changing faster than past experience would suggest." Secondary hazards quickly emerged. Rivulets of heated water melted narrow trails in the snow, causing small debris flows in the White River Basin. Shelters near treeline saw an influx of campers redirected by new evacuation advisories. Rangers made rounds closing off trails, citing risk not as a suggestion, but as a necessity. One hiker remarked, "It stopped being a mountain and started being a hazard." Rising concern centered on a feedback cycle. Each pulse of gas loosened more snow, exposing hotter ground, intensifying visible emissions in turn. Stream sensors, designed to monitor water chemistry, picked up abrupt rises in both temperature and acidity, signs that the venting of gas was affecting far more than just the air, but was influencing water and local geology as well. Early scenario modeling by Dr. Vasquez and colleagues considered several outcomes. In the best case, the system would reach a new equilibrium and emissions would subside. But if underlying causes, such as depressurization within the magma chamber, the introduction of surface water at depth, or a shift in geological stresses continued, risk could escalate. These systems can be non-linear, Dr. Vasquez noted. Once underway, they can shift rapidly from apparent calm to active crisis. This ambiguity, each gas pulse carrying both the hope of pressure relief and the specter of greater hazard, now defines the region's nervous mood. Scientists scrutinize each new reading, locals scan the sky for further activity, and the machinery of public safety pivots between hope for resolution and readiness for escalation. So what comes next? Is it possible to forecast how this story will end? The answer, filled with uncertainty and requiring sustained vigilance, is that only with time and close observation will it become clear whether calm or crisis is at hand. As dusk settled in, the feeling of urgency only deepened. The eruption of gas has had ripple effects on the landscape, water, and air that extend further than any model predicted. The breakthrough at the Burr steam heating pipe triggered a complex scenario: increased emissions and unstable slopes on one hand, altered stream courses and redirected runoff on another. These interplay in ways not fully captured by prior preparedness plans. What worried responders and scientists alike was the persistence of the hazard. Unlike many seismic events that end quickly, outgassing at Mount Hood continued for much of the day and into the night, feeding columns of steam that persisted even as the sun faded. Drone footage showed vapor cloaking the southern slopes, melting away familiar landmarks and creating an atmosphere of uncertainty. For communities below the mountain, the impact was more than theoretical. Main routes between lodges and neighboring towns were closed, blocked by barricades and guarded by county officials. Communication, already complicated by mountainous terrain, was further stressed. Static-filled advisories and interrupted cellular networks marked the evening. Sarah Yoon, the regional emergency management lead, encapsulated the mood. Every plan we had is being tested by the mountain's unpredictability. It is not about control or containment. It's about adapting as the situation evolves. In the labs and field bases supporting the response, data gathered at unprecedented speed often contradicted expectations. Water sensors set for icy mountain flow now recorded temperatures found in geothermal systems. Pressure gauges noted aberrations unlike any in the prior decade. The sheer count of unknown variables exceeded even those of earlier events. Despite the mounting uncertainty, Dr. Vasquez's team remained the touchstone of the region's response. "We depend on our instruments to see beneath the surface," she explained. "But right now, we're learning on the fly. The mountain is teaching us in real time, and every hour brings new surprises." If emissions were to keep building, if shifting gas flows revealed larger changes at depth, the next phase of activity might arrive without warning. Through the night, the sense of urgency intensified, hour by hour. Public anxiety deepened alongside scientific concern. For every official update and every reminder to heed trail closures, new rumors and speculation sprang up online. Was this steam a prelude to eruption, or would it dissipate with little further impact? Could communities at the mountain's base be threatened? Would the region's iconic landscapes be changed forever? The lack of simple answers was a source of both tension and resolve. Night yielded little in the way of clarity, only the continued search for patterns in the darkness, and efforts by authorities to keep people informed and safe. Ranger teams patrolled cordoned zones, their headlamps carving arcs through the mist as they checked routes and updated signs. At midnight, a fresh group of experts arrived to join the watch. Among them, Dr. Akira Okabe, visiting from an internationally acclaimed volcano monitoring agency. It is rare to see gas releases of this scale and persistence outside clear-cut eruption phases, Dr. Okabe observed. The unpredictability itself marks this as an event of concern. Looking back at Mount Hood's history, scientists note that its most likely future eruption would probably involve the formation of a new summit dome, more gradual than explosive, but significant all the same. Yet today's readings of gas, steam, heat, and subsurface chemistry signal a system more complex than familiar patterns provide for. Subscribe for real-time analysis, ongoing updates, and expert perspectives on Mount Hood's evolving story. Join the conversation. Vigilance and preparedness are our best resources against the unknown. Beyond urgent headlines lies a sobering reality. Mount Hood's outburst is not just a physical phenomenon, but a stark reminder of how much about the volcanic world remains unpredictable. As steam drifts into the night and emergency beacons pulse along the ridges, it becomes clear that no map, no historical chart, no technology can perfectly foretell a mountain's next move. The search for meaning and for effective safety planning is more essential and more urgent than ever. Dr. Vasquez, reviewing the last sensor reports before dawn, summed up the lesson in quiet terms. Each of these events reveals our limits, not just in knowledge, but in certainty. The best strategy is vigilance. The mountain speaks through signals we're learning to interpret. Our job is not to predict the future perfectly, but to stay alert and ready to respond. As light returns to Mount Hood, its summit still shrouded in vapor, the mood across the region is unchanged. A tension that abides, a sense of respect renewed, and a readiness that feels less like preparation and more like adaptation to the unknown. We will be here with every update, tracking, listening, learning. For what happens next at Mount Hood may shape not only today, but the future for everyone living in its shadow. Subscribe for continuing updates, scientific briefings, and each new chapter as the story at Mount Hood evolves. Share your questions, what you have witnessed, and how you think we should prepare. Join the discussion, stay alert, and return for our next report as we work to uncover what lies ahead
for one of America's most enigmatic volcanoes.